Okay, it's Tuesday, it's 1 o'clock. That means it's time for our HDF clinic. Welcome everybody. Lots of things going on in HDF land and not reflected in the questions though, because when I checked earlier, yeah, nobody has submitted any questions, but that's fine. We got plenty of material. But before I go into that, let me ask for the folks attending here today, if anybody has a question about HDF5 or about one of their applications or something like that. Anybody? No? Okay, then I'll pause many more times. I'll just jump right into it. Before I come to these questions, I want to start with last week's highlights. There was one announcement, but also another announcement that I want to call your attention to. Number one is we released HDF5 1.10.8, and I have the post, the announcement linked here, but also the release notes. And I just picked from the release notes, I read through them and picked the ones that struck me that I thought might be relevant or are most relevant to users here. Number one is that if you are a user of the HDF C++ API, I might say old HDF C++ API, Cmake won't build that by default any longer. So if that's something you care about and you are using Cmake, that might affect you. Beware that it's not enabled by default. So you can still enable it, but don't be surprised if it's not there next time you try building it. And you use Cmake and 1.10.8 or newer. The second thing, the minimum required for Windows builds using Visual Studio, the minimum version is now Visual Studio 2015, I believe, although I have not tried it lately. That's true for all editions, so it doesn't really matter if you have the Express or Professional or Enterprise or whatever other editions there are. It's Visual Studio 2015, that's the important thing. On macOS, I think that's something that's been requested many times. On macOS, you can now build universal binaries. I believe the release notes, actually let me check if they stated that for a specific version of macOS, or if this is, since I'm not a macOS user, I'm not competent to talk about that anyway. But let me quickly check here if there was something. macOS execution Intel ARM Silicon, yeah, it doesn't call out a specific version of macOS, but be careful there. I think that might apply only to the latest or definitely newer versions of macOS. But anyway, so if you have one of these newer versions, you can now build these universal binaries, I think, which was a feature that was important to many people and convenient and whatnot. There is also now a Cmake option to build HDF filter plugins as an external project. So that has to do with your distribution. And I think, as is the case already with szip and maybe some of the other methods, that you can have a targz archive, for example, side by side with your source code. And then if you specify that in Cmake, so let's say you have bzip or LZM or some of the other filters, you can now build them in the same way as external Cmake projects. The other thing is, yeah, you can use auto tools in Cmake both to produce the Doxygen documentation, provided you have Doxygen installed, of course. And for MingW users on Windows, that is, although there might be MingW also under Linux, although I think it's really mostly relevant to Windows, is you can now, with Cmake, statically link to the GCC libraries with MingW. File locking, I think we covered this on an earlier episode, but that now works on 1.10.8 with 1.10.8 under Windows. And then there were performance improvements for point selection. So in particular, this function h5s get select element point list. I think Neil implemented something with sort of caching, since these point lists are sort of processed in blocks. I think he is caching sort of when he processes a block, the next point from the next block, and then so he doesn't have to, next time this function get called, the library doesn't sort of have to rewind and go over that whole point list again, but you can sort of pick up where you left, so to speak. So that's a good performance boost. And then I remember the post, some people reported that in HDF5 you can have these data transformation functions, simple algebraic expressions, but it turns out that in the case of the identity transformation, so just specifying x rather than x times x or something else, x plus x. If you specified the identity, so basically the transformation that doesn't do nothing, the problem with that was that in particular when you used parallel I/O, that data transformation broke collective I/O and would default to independent I/O, which then triggered that if you were doing compression or other filters with parallel HDF5, which require collective I/O, you kind of killed that. But that's no longer the case, so it was fixed. And so now, if you, for some reason, to make your application easier and whatnot, you have this transformation, which is the identity, it's not going to kill collective. And so if you're doing parallel compression and things like that, that should be good to go. Same in the same vein. There's also, so reading through the release notes is interesting to some people like me, and many of you probably. I would also like to point your attention to, we started publishing an interesting figure where you can see sort of the changes, potential changes in performance that you might see with HDF5. Now you have to take that with a pinch of salt, in the sense that these are just, I think, two different benchmarks for which we recorded here this change in performance. And so, as they say, your mileage may vary. So I think this is here, that first figure, it says time CGNS make check. So CGNS is this computational fluid dynamics code. And this is sort of starting with 187, going to 112.0 or 112, the current head of that 112 branch. You see the performance that, yeah, with the 110.0, there was a substantial loss in performance, but that performance by and large has been recovered. In fact, the performance is better as you compare to 187. And here is just a right large number of data sets benchmark again. I don't know why we are going back to 180 here and not here, but I can try to find out why that is. And again, you see that we lost in 110 quite a bit of ground. The latest figure is not here. It goes to 110.7, and then I know there were some changes to the macros and so forth in 110. I don't know. So in develop, I don't know if those changes have been already brought forward into 110, but they yielded, I think, pretty substantial, meaning 10% plus performance improvements. And yeah, the latest numbers are not yet reflected here. But nevertheless, this is an interesting graph to follow if you just want to sort of get a sense for, well, how much performance did we lose this time around? This might be a figure, an interesting figure to look at. But as I was actually looking at this figure, I read something that caught my attention. And I created a question for myself, and so I don't know the answer to that question right now, which is that here, where we talk about compatibility and performance issues for 110, it says here, not all HDF 110 releases are compatible. Well, and then we discourage you from using 110.3 and earlier. I don't really know how to read this. What does that mean? Does that mean API compatibility? Does that mean file format compatibility? I doubt that means file format compatibility. But so since this is rather imprecise, let's put it that way, I took it as a question to myself when I prepared this material this morning, that to clarify, and I'll come back next time and we'll try to explain what that exactly means. Okay, one more comment. The swimmer, that's the single writer multiple reader VFD beta 1 is available, and we really would like as many of you for which this is an interesting use case to try it. Here's the link to the forum post, the original announcement, and the link to the GitHub branch. We would appreciate it if you could try it, because I think the folks who are working on that, they really want to get that into release shape. So it's not supposed to be buggy or anything, it's supposed to just work. And that's why we would like to see as many people try it. Anyway, forum is next, but before I go there, are there any questions?
Yes, Gerd. Hi, this is Marta.
Hi.
Sorry, it may be obvious, but in fact, when I saw the announcement of the release 1.10.8, then I remember you have 1.12. So what are the differences between the 10 series and the 12? I would expect to continue like 12 dot something. So I was surprised to see.
Excellent question, thank you. Well, the main difference is there are features in 1.12 that are not available in 1.10. The most prominent one is perhaps the virtual object layer interface. That is something that was introduced in 1.12.0, and that's not something that exists in 1.10. So in 1.10, there are no virtual object layer plugins, if you wish, for version 1.10, and there will never be, because we will never sort of backport or bring that feature back to 1.10. So if virtual object layer interfaces is something of interest to you, in a way you have no choice. 1.12 is the way to go. However, in terms of stability, I think we test 1.12 as rigorously as we test all the other versions. So I think if your concern is, well, do these different versions all get the same care in terms of testing? Yes, absolutely they do. So for me personally, if I would admit, well, there's nothing really to be ashamed of. I use HDF 1.8 quite frequently still, because it's still maintained. The latest version is 1.8.21 or 22, I believe. It's stable, it's been around. Going back to that performance graph, it gives you actually in some applications, again, this is not across the board, there are some applications where 1.10 or 1.12 performs better, but I also have a few applications where 1.8 actually performs better than 1.10 or 1.12. So unless there is a feature that you are using that was introduced with that particular version, let's say you care about 64-bit identifiers. Well, those 64-bit identifiers didn't exist in 1.8, or you use Swimmer or something like that. That didn't exist in 1.8. But if you don't use those things, there is practically no reason to choose a higher version, because as you can see from these graphs, at least the lower one here, is there is a degree of loss in performance, and if that's critical to you, then I would definitely choose the version that is the fastest, that has the least overhead. So does that answer your question?
Yes, eventually the changes that you just show about the 10.8, are they also included in the 12?
Yes, yes.
Okay.
So I think you can assume, unless there is a specific feature that turned out to be, and I can't give you an example, I'm just making this up. And I think it sometimes happens that we deprecate certain things in a newer version. So there will be things in 1.10 that were deprecated in 1.10 that were still kicking in 1.8, and then for some reason we decided either that API needs to be changed a little bit. For example, I believe going from 1.8 to 1.10, I forgot which one, we introduced a new API for managing references. The old API is still there, so you can still use 1.8x style references. This is this H5R API in 1.10. However, there's a new API, and then I forgot in 1.12 if that old API is still there in 1.12. So there is some deprecation going on going forward here. But yeah, if this is a substantial feature like Swimmer and so forth, definitely there is Swimmer in 1.12, but there's also the object layer plugins and things like that. And so yeah, so you can assume if this is a stable, well understood, tried and true feature, it just keeps moving forward with the newer releases.
So eventually for users on a facility, we should have at least a 1.8 latest version, and then some of the others, the 12 ones, in case they need additional functionality.
Yeah. So I think just in terms of also keeping a sense of the API, the HDF5 API usage in your code, it definitely doesn't hurt, even though you may not use it in production. If you have a code with HDF5 1.8 in production today, if you have some time, try building it against 1.10. Make sure that it builds without any problems. You probably have some kind of test suite or something like that. Make sure it tests. If you want to do a benchmark and see, did we lose performance? Did we gain performance? Absolutely the right thing to do. Now, at the moment, since you can, in a way, leapfrog, if you wish, from 1.8 to 1.10, that's also a good thing. So if you are thinking about, okay, I have this 1.8 code, it definitely, in perspective, I want to modernize or make sure that it works with 1.12, then that might be a good reason to say, well, I'm going to skip 1.10 and go straight to 1.12, because why then do this a second time?
I think eventually a second question is in the previous slide where you have all the list of changes that you want to share. So the first one, the Cmake no longer builds the C++ library by default. Is that a Cmake specific situation, or
yes.
is a particular?
So the auto tools, I think the auto tools still will build the C++ API by default, but no, not in Cmake. So if you are using auto tools, you are fine. I don't know, I cannot speak for the release team and say if they have plans to do the same thing for auto tools, but this is definitely true for Cmake.
Any Cmake release, particular number, or?
Oh yes, there is a requirement. I mean, we can look, or I can take that offline. But yes, we have certain minimum Cmake requirements. Actually, let's quickly check here. It's probably, I mean, usually it's in the release notes. If we sort of bump that minimum Cmake version required, then we put that in the release notes. But if I quickly go to GitHub and I can check it for, just for simplicity, I'm going to quickly check where GitHub, where develop stands. So if I go into Cmake list txt here, So here it says Cmake minimum required 3.12. So I would think that for 110 and 112, it's similar, but let's just for argument's sake, so let's take the 110 master, for example, which at the moment is pretty much identical to 110.8. So you see it's 312 is the minimum Cmake version required.
Okay, thank you so much.
Okay, great. Thanks for the question. Okay, what's been happening on the forum? Well, a lot. In fact, last time I had something that I had prepared, but then forgot because for some reason I commented it out in the org file. Someone had asked about obtaining information about the offsets, the actual locations of chunks for chunk data sets in the file. And the link is here. And yes, the solution is, and again, it's sort of one of these things. There is a function that is currently in the development branch, and I imagine will be in the next 112 release. I believe it's not currently in 110.8, for example. It may get there eventually. But yeah, there is a function that you can use to iterate over all the chunks in a data set. And then since you will have a callback registered, in that callback, you get information about the currently visited chunk, so to speak. And then, yeah, from that, you can get the address and so forth. And the performance is actually pretty good. Because I think the user that asked this question, he was concerned, or he saw that there was a lot of overhead because this function h5 get chunk info is there, but then you have to wrap your iteration, so to speak, around that call and just call it repeatedly. Whereas if you call h5d chunk iter, it all stays in the library and is very likely to be much more efficient. So I had skipped that last time, but I just for completeness put it here. Another interesting question somebody asked, what about using HDF view, having a file, and then maybe while another process is writing to it or reading from it, or maybe even making modifications in HDF view? Well, while that may sound like a plausible or appealing thing to do, it's really in a way a bad idea, except for very specific use cases. So for use cases where this would make sense, not necessarily with HDF view because it doesn't open in swim or read mode, you have a single dedicated writer and then multiple independent readers that do not communicate with that writer, and that's exactly what we have Swimmer support in 110 or the upcoming Swimmer VFD, which actually adds some interesting real-time capabilities and the ability to also create new attributes and so forth. Otherwise, this is a bad idea because, and this is a figure that I just repeated here that we had earlier in one of the earlier clinics. When you think about the state of an HDF5 file, of an open, I should say, an open HDF5 file, then that state is really divided between, logically speaking, at least two places. There is part of that state resides on disk, and part of that state resides in memory in terms of what the application sees of that file and thinks about that file, so to speak. So if you were now to add other processes to this picture, what would happen is there would be a partial state remaining on disk, but there would be sort of one partial state in RAM for one process, another partial state in RAM for another process, and so forth. So what you will see quickly is that, well, then you can ask, well, what is the true, in double quotes, state of that file? How do you combine potential changes, since we are talking about writing here also? How do you reconcile changes that, let's say, HDF view as one process made, and then changes that another process running in the background somehow made? What is the true, in double quotes, logical state of that HDF5 file. And that's where it gets tricky, and that's where you get into issues like corruption and whatnot. So generally speaking, this is a bad idea, and don't go there. Again, unless you have a very specific use case like swimmer in mind. And let's see, I'm just, let's see, we can probably cover 2 more things at least, unless there's a question. Let me pause. Since this is about your questions, you don't have to listen to what I found interesting. We want to hear what's interesting to you. Any other questions so far? No? Okay, good. Then I'll just continue. Someone was asking a very interesting question about, he phrased it as appending HDF5 files in parallel. So I quoted parts of this. Basically, the user is saying that he has thousands of HDF5 files and he would like to merge them into a single file. So basically appending all the groups and data sets and so forth. And the assumption is that they have all different names and so forth, so there won't be any name collisions or path name collisions, that is. And oh, I apologize, I copied that twice here, but yeah, I'll fix that. And preferably, of course, you would like to do that in parallel. And just to make this more interesting or more complicated, the data sets are also chunked and compressed. And then he has a proposal how to do that. And yeah, I would say that's a tough one. Sort of logically, you can think about it this way. There are probably 2 kinds of approaches that you can take. Number one is you want to avoid copying any data. And there is a solution for that, because you could create what we call a stub file or a proxy file, where you basically create references to the existing data, to the existing objects via external links. That's fine. Of course, there is going to be a performance cost to that, in the sense that every time you access a data set or a group or something like that, there is a level of indirection. And yes, once you've gone down a certain path, there will be some caching. The library definitely caches some metadata, so it's not that you have to constantly open and close files, but if you sort of start iterating over these files and so forth, of course, that cache has a finite size, and then as you transition from files, other stuff might get kicked out of that external file cache. And if you go back to if you want to go back to an earlier file that where the metadata has been evicted already, then yeah, so those are the types of problems that you might expect performance-wise. But if you were to process them in some kind of sequence, that would be okay. So that's the approach. Don't copy any data. And the second approach would be where you say, well, I really want a self-contained HDF5 file, no external links and so forth, where you really have to copy some data. So then, of course, I would say, yeah, you have to copy the data as fast as you can. And unfortunately, the MPI parallelism complicates that a little bit. So if you look at the exchange here, there is actually a function. So for example, since the requirement was data sets are chunked and compressed, and you might think, well, okay, I got to read the chunk, decompress it, recompress it, and write it. And that looks pretty cumbersome and a roundabout way, because at the end of the day, all I want to do is really copy that chunk. And that's what you want to do. And we have actually these 2 functions, read chunk and write chunk. And so you can transfer the data of these chunks without compressing or decompressing. So that's as efficient as it gets. However, unfortunately, these 2 functions are not supported in parallel currently. And so if you still want to go down that path, what you could do is, since you are dealing with a lot of files, you could basically have multiple MPI ranks read from multiple files independently, and then basically buffer data in memory and then have, let's say, one dedicated process writing to the file, and that way sort of utilize your I/O subsystem to a degree. So there was no specification about or no specifics about how big these files were and so forth. And so yeah, but that's a tough one. And it might be interesting to think about writing a tool for that. But unfortunately, this is, and then it depends on the use case. If just a proxy file is good enough, well, then that's an easy one. But if you really want to physically compact all that, then that's a little harder and requires quite a bit of work. Before we go, time is up. I want to mention there was this other question about reading variable length data from an HDF5 file with the C++ API, but the C++ API is not that important here. It's a matter of, and the user was so kind to include an example. It's basically matching, having matching writes and reads. And in this particular case, I think the user is writing variable length double sequences. And he is using, we talked about this many times, when he writes or she writes, the user uses this HVL_T structure in memory, but on reading, they use basically a vector of double. Well, those two don't go together. So you have to make sure that, and that would have been my topic for tips and tricks, but I'll come back to that next time. Sort of call it the necessary condition for reads and writes to match. And but yeah, we'll come back to that next time. But take a look at that if you are interested in that. And that's going to be it for today. Thank you for coming. Thank you for asking questions. And we'll be here next week. Thank you.